Hi, in this program we're going to take a look at acid-base indicators. Acid-base indicators can be viewed as an equilibrium between, in this case, a conjugate acid and its conjugate base, both having a different color. Let's look at how this indicator behaves in an excess of hydrogen ions. In that situation, it would shift to the left. Similarly, if I remove H+ ions by adding OH ions, it would shift to the right. So I have colored ions that are present both as the conjugate acid and as the conjugate base. Let's look at how we can use this in a pH curve to determine when we reach what we call the equivalence point. The equivalence point is that point at which we have equal moles of acid and equal moles of base. The end point is the pH at which our indicator changes color. Let's examine the color change more closely. At the start of the titration, the solution is a weak acid, and in this case the indicator would appear a green color. As we add OH ions to the solution, our reaction shifts towards the right, using up the green ions and producing more and more of the blue ions. Eventually, at a pH of about 5, the two concentrations would be about equal to each other, and as you continue to add the base, it would eventually turn blue. In this case, I don't have a very good choice of indicator to use for this titration. In an ideal situation, I would like both the end point and the equivalence point to appear at the same time. So this would be a better choice of an appropriate indicator. Indicators can have an acid constant, and at the point of transition, when we're moving from, in our case, a green to a blue ion, those two concentrations would equal and hence cancel out. So the Ka, the acid ionization constant, would equal the hydrogen ion concentration, or the pKa would equal the pH. In your IB data booklet, you have a list of indicators and their pKa, which is the ideal pH at which they change color. Let's take a look at a question involving this data. What would be the best indicator for the titration of ammonia, a weak base, with hydrochloric acid, a strong acid? In that case, our salt would be a weak acid. So I would have to look for something that would have a pKa in the acid range. So either bromophenol blue or methyl red would be good choices here. Let's see if we can narrow it down a bit further. Here's the titration curve for this example. We can see at the equivalence point that pH changes at a value just a little bit above 5. So based on the two choices I have, the methyl red would be even a better choice of indicator. Remember, questions are always welcome.